Hello and welcome back to our journey through the solar system. So today we are making it all the way out to Mars. We finally are making it out past the Earth. So Mars is named for the Roman god of war, who is also known as Ares in the Greek pantheon. Mars is often called the red planet for its beautiful and distinctive reddish color that is visible even by eye in the night sky. So why is Mars so red? Well, it's actually because it has iron oxide, quite a lot of iron oxide in the regolith on Mars. And iron oxide is basically rust, so it's rusty dust on Mars. And it's also the same thing that makes your blood red, so rusty, dusty, bloody Mars? You see why it's named for the god of war, huh? So although Mars is actually more physically dissimilar to Earth than, say, Venus, it actually shares a lot of really important properties with Earth. One very important one being that Mars is technically located in what would be considered the sun's habitable zone. So the habitable zone is basically the area around a star that liquid water could exist on the surface of a planet. And this is true of Mars, although we have not found any liquid water on the surface of Mars. There are a few places that it could potentially exist, but not very many because of the very low atmospheric pressure, which means that it's just not really able to hold on to that liquid water. But it does have frozen water in its ice caps, and we've seen a lot of evidence that there was flowing liquid water on the surface of Mars in its past. And there have been some hints that there may have been flowing liquid water just in the past few years in some sort of temporal cycle. And so, water on Mars is certainly a very interesting and open question. A solar day on Mars is about 24 hours and 40 minutes, so it's very similar to an Earth day. And a day on Mars is called a sol. Mars also has an axial tilt of about 25 degrees, which is similar to Earth's 23.5-degree axial tilt. And it has a mean surface temperature of 210 Kelvin, which is about negative 82 degrees Fahrenheit. Now, okay, that's obviously not great. Remember, the Earth's mean temperature was about in the 50s, so negative 80, we don't love that. It's not as crazy as, say, Venus. Now, the ways in which Mars is different than Earth, a lot of it comes down to its size. So Mars is quite small. In fact, it's anomalously small. It's not the smallest planet, that is Mercury, but based on its location in the solar system, getting a planet the size of Mars there is actually quite unusual. And this kind of represents a challenge for formation models of the solar system because they need to be able to reproduce a small Mars-type planet. Basically, given Mars's size, we think that it would have gone on to collide with other objects of similar size to form a bigger planet like Earth or Venus, if not for the influence of Jupiter in that region of the solar system during that point of terrestrial planet formation. Now, because it's so small, the surface gravity on Mars is less than 0.4 g, or less than 40% of what it is on Earth, and its surface pressure is only 0.006 atmospheres. So 0.6% of Earth's surface pressure, because it has trouble holding on to an atmosphere. It's not very big. Also, Mars doesn't have a magnetosphere. This means that its atmosphere that it does have interacts more directly with the solar wind, which has all of these charged particles that can ionize the atmosphere and help strip it away and make it even harder to hold on to for poor little Mars. Now, the atmosphere that it does have is about 96% carbon dioxide and about 2% each of argon and nitrogen, and then trace amounts of things like water and other gases. In addition to the gas, the atmosphere on Mars is actually quite dusty. The regolith of Mars is very fine and it gets kind of brought up into the atmosphere, and it can have these dust storms, some of which are localized, but it can even have global Mars-wide dust storms. Here's an image that you can see of kind of this dust storm enveloping Mars. You can see how it kind of shrouds the entire surface because dust is not see-through. And in fact, dust from Mars seems to be the prime contributor to the zodiacal dust, which is kind of the dust that reflects light in the inner region of the solar system. And this was actually measured very recently, kind of on accident, by the Juno space probe on its way to Jupiter, which was really interesting. But we don't actually know how that dust gets kind of from Mars into the inner solar system to become this zodiacal dust. But Mars is very dusty. Mars has two natural moons, Phobos and Deimos. However, unlike the Earth's moon, these are quite small, and they are not large enough to have become spherical under their own self-gravity. That is, they are smaller than the potato radius. If you watch my TikTok, you know all about potato radius. And the exact origin of these moons is actually not entirely clear. Kind of one of the leading theories is that they're just captured asteroids, but they do seem to orbit in a way that is a little bit surprising if they were a captured asteroid, so big question mark how they got there. And in fact, Phobos is in an unstable orbit. Its orbit is tidally decaying. And so sometime in the next, 30 to 50 million years, Phobos is actually going to get pulled apart as it gets too close to Mars and kind of disintegrates. So Mars, being relatively close to us and having that beautiful red color, has a long history of being observed by humans. The earliest recorded observations of Mars date back to the 2nd millennium BC and ancient Chinese and Egyptian astronomers. Cultures as early as the ancient Babylonians and ancient Greeks were using models to calculate when and where Mars would appear on the sky. Although it wasn't until the 16th century and a man called Copernicus that these models became heliocentric, which is a pretty important component of the solar system model. The very first observations by telescope of Mars were made by Galileo Galilei in the year 1610, so about 400 years ago. For centuries, astronomers were observing Mars through telescopes. They were making drawings, they were identifying surface features, such as this big dark spot, which is called the Syrtis Major Planum, and the bright polar ice caps. And rather famously, there was an Italian astronomer who drew these kind of straight lines from his observations of Mars that he called canali. Now, this in Italian meant channels, but it was kind of mistranslated into English as canals. And this was in the kind of late 19th century, and so this led to a lot of speculation about, because canals kind of implies constructed, artificial, and so this led to a lot of speculation about civilizations on Mars that might be existing. It actually turned out that these channels or canals were actually just an optical illusion because at the time, remember, there were no cameras, there were no CCDs. These observers were just observing Mars through a telescope and trying to draw what they saw. And they would often spend hours and hours looking through the telescope and trying to draw it precisely. And so that kind of led to opportunities to introduce this sort of human error where the human eye thought that it saw something that wasn't there. Humans are really good at recognizing patterns, even ones that don't exist. So these remote observations of Mars were really useful, more than, say, the Venus observations, which were really kind of stymied by the surface, or stymied by the clouds on Venus, and Mercury is so small and far away, but Mars is pretty close and it has a pretty clear atmosphere, so we could actually make quite a lot of observations from a distance. But it's hard to be going there in person, or in machine, as the case may be. So the very first mission to Mars was Mars 1 by the Soviet Union back in 1962. Now, this mission actually failed because there was a communications failure before it actually kind of arrived at its flyby by Mars, but it did launch and travel successfully. We just lost communication with it. And then the first successful mission to Mars was NASA's Mariner 4 mission, which launched in 1964 and then actually flew by Mars in 1965 and returned images, including this beautiful, beautiful image. And this was the first kind of close-up image of a planet taken from space. In total, there have been 49 missions directed to Mars, and 11 of them are actually still in operation. Mars is a very popular target. Those 11 missions are from NASA, the Mars Odyssey, the Mars Reconnaissance Orbiter, the Mars Science Laboratory, aka Curiosity, Maven, InSight, and Mars 2020, aka Perseverance and Ingenuity. The ESA has Mars Express and ExoMars 2016 in collaboration with Roscosmos. The ISRO, which is India, has the Mars Orbiter mission. The MBRSC, which is from the Emirates, has the Emirates Mars mission, aka HOPE. And CNSA, which is from China, has the Tianwen-1. Now, the surface of Mars is a lot more accessible than for Venus and Mercury because Venus, hellscape, and Mercury requires quite a lot of delta V to get to. So Mars has been a prime target for space missions, especially landers. And by the time this video goes up, we should know if we have successfully flown on Mars, which I don't know about you, but I think that's so cool. Ingenuity is just adorable. Also, as part of the Mars 2020 mission, really excitingly, the ESA is going to partner with NASA to actually return some of those samples. This is going to be a sample return mission. So that will be the first time returning samples from Mars. It's pretty cool. Okay, so I said that Mars is technically located within the habitable zone of the sun. So the big question then is there life on Mars? Or was there life on Mars? And the answer is, we don't know. So we have not found any direct evidence yet of life on Mars, either in the present or in the past. However, there is quite a lot of evidence for formerly having flowing water on the surface of Mars, and they've even found that in the past Mars had some nutrients that would be available for life to use if there was life. And like I said, unconfirmed, but speculation that there was actually flowing water in the very recent past as well. So these are very exciting pieces of evidence that Mars could have been or could have had life in it at some point, even if it doesn't anymore. And this is actually a prime part of the Perseverance mission. Now, of course, Curiosity and Opportunity were also both looking for signs of life on Mars, but this was really what kind of Perseverance was tailored to, and it chose this landing site in Jezero Crater because it was basically a former lake on Mars, and this is former delta, which if you think about deltas here on Earth, they have this very rich sediment, and that would be a really prime place for life to kind of get fossilized and to be later dug up if we could, go there billions of years from now. So that's kind of the idea behind Perseverance, is that it's in this location that could be really great for finding evidence of past life on Mars. And so yeah, we really are very curious and eagerly trying to figure this out about Mars. There's a lot of people that do a lot of research related to astrobiology, specifically focused on Mars. And kind of a, related question then is, well, can we live on Mars? I think Mars has probably captured the imagination of humankind more than any other body in the solar system as a potential home for humanity. This is a common theme, not only in science fiction, but also in, real life. I mean, I think everyone knows about Elon Musk and his determination to found a colony on Mars in his lifetime. So the idea is definitely out there. Now, the concept of terraforming Mars, that is kind of making Mars into a habitable planet like Earth, it has a lot of debate around it. For one, there's kind of an ethical side to it. Like, do we have a right to Mars? Do we have a right to kind of make Mars into just an extension of the Earth and humanity? And then, of course, which humans have that right? Because, we're not going to send 7+ billion people to Mars, and so who is going to Mars, and what is kind of going to govern that? That is a big part of the terraforming discussion. But on the other hand, it's the many, many technological challenges associated with terraforming Mars, and is it even possible if we did decide that it was ethical? It's cold, the atmosphere is too toxic and too thin, the soil itself is literally toxic, there is no nice protective magnetosphere, the surface gravity is quite low, and we don't even know if humans can live long term in that kind of surface gravity. It's a lot. A lot of unknowns and a lot of challenges. And some other methods of colonization, such as domes or digging into the surface and living underground, can address some of these issues, but maybe not all of them. So there isn't really a definitive answer to this as of right now, but I don't think that people are ever going to stop trying. Like I said, I think it really captures people's imaginations and aspirations, and it's part of, a large part of humanity has that kind of exploratory, frontier, pioneering drive. I know I, for one, would sign up to be a Mars colonist. Although, then again, I'm not sure if I could live without beaches and ice cream and the feeling of the sun on my face and the way flowers look in the spring. Okay, maybe I wouldn't sign up to be a Mars colonist. But in any case, perhaps a Mars colony is in the future of humankind. I cannot say. I don't think anyone can right now. So Mars is one of the most important and exciting bodies in the solar system. It is our beautiful little red brother, and we love Mars. Well, I love Mars anyway. I hope you do too. I hope you learned a little bit of something, and I hope you will come back next week when we will be talking about Jupiter, king of the planets. Thanks for watching. Have a good one. Bye.